Welcome to Unit 2 of our course Procedural Programming. So Unit 2 is our first real working unit after Unit 1, where we went through the organizational things of our course. Okay, now this unit is divided into two sessions. Session 1, which I show in this video, is dealing with the UNIX shell, and the second session in the next video will show you how to make very first and tiny C program. Okay, session 1. We try to work with a shell. So just to start from a point where we are pretty familiar with graphical user interfaces, we know them all. We have windows with icons for programs and documents, and if we want to do something, we move our mouse cursor over the program or document we want to open. Here in this case the Atom editor, and if we click or double click on the icon, it starts. On command line interfaces, however, this is a little bit different, and we have to change our workflow a bit. So you see here on the bottom we see the shell window, and you see a lot of text, no icons, and if we want to start the program here, we have to type in a command. So for our example with the Atom editor, we have to type in the command atom, hit return, and then the program starts. This means that we have to memorize a few commands to do our work. Yeah? And well, basically, sometimes one can't avoid, and one runs across a system which has no GUI, and in this case you need to know how to work with a shell and command line tools. In particular, I want to show you how you can work with files and directories using the command shell, and I'll show you how you can get help if you get stuck somewhere, and finally I'll show you a few commands where you with them you can monitor processes and users on your system. Good. These basic UNIX commands for dealing with directories and stuff, I'll show you directly live on the system. So I switch from the presentation here directly into the shell. We fire it up here. I'll make it larger in a few seconds, and then we bring our one window of our GUI. We'll bring up two to make things better visible on our system. So let's increase the size a bit. Okay, and if we move over there, you can also see the effects of our work we do in the shell. We can see in the GUI. Okay, so here you can see this is the shell. We have some kind of information about the last login and stuff like that, and here you can see the name of the machine you're working on and your login name, and from here you can start typing and placing your commands. So first of all, try to get a little bit of an overview where we are. As soon as we fire up the shell, we are placed in a special directory, and this is the so-called home directory, or maybe all know this. Here in the GUI you can see this is uh, the directory which has the name of your login, and you can see uh, the all the files and directories which are in your home directory. And we can just first of all we just see where we are. We can type in our first command, and this is pwd print working directory, and if we press return, then we get the information we are in users, so slash users slash Peter. This means we have on the top of the file system there is directory users, and in this there is the directory Peter, and we are now in this directory. Well, here in the GUI you can see that we have different directories and files in here, and we can't see them here unless we are typing in another command, our second command here, and this is ls for list, so means list the directory content. If we type return, then we can see all the directories in the shell, and you can check it out. This is all the content here can be seen here too. Good. Now let's go to some place which is a bit safer, where we can play a little bit around. We will move then, just to show you in here in the GUI, we'll go into documents, and there is a directory temp, and we will go into here, so you see in the GUI that this temp directory is empty. Okay, then we have to move our working directory, or we have to move into this directory, because we are still, you can see we are still in our home directory. To change into a specific directory, we have another command. This is cd for change directory, and we have to state the name of the directory. So this is the first one we have to go into is documents, and then we change into from here from documents we change into the directory temp, and again ls, and we see yes, it's empty, as we can see here. Good. Now let's do something in our directory. We add some content here. First thing we can do, we create a new directory in the temp directory, and for this we have another command. This is mkdir for make directory, and we have to give it a name, something like first shell try. Yeah, okay, it's good. Return, and it's here. You can see it in the GUI, it appeared already, and also here in the shell we can type in ls, and we can see our directory. Now as a next step, we create a new file. We need an editor, as you've seen it already on my system here. I have the Atom editor. On your Linux boxes you have an editor. This is called gedit. Yeah. But since this is a Mac system, I use this editor, Atom, and we have to state the file name. Well, creatively we call it first file.txt. Okay, return. So it takes a while for the editor coming up, but it's here already. We can see here in the editor we have our first file. This is empty. Just type something in. Oops. Maybe this will become our first C program in a while, something like this. We save it, and you can see here in the GUI the file appeared. And let's go to the if I find it, let's go to the shell again. Here we are. And okay, so if we type ls, we have it here again, first file.txt and first shall try, as it can be seen here in the GUI too. Good. Now maybe it turned out that this text file is not properly placed, and we want to move it to another place. So something we could accomplish in the GUI, where we just click on the file and drag it onto the directory here. But since we're, well, what happened here? First shall try. It happened actually that we moved it already in the GUI. Okay, let's move it out again and close this window. Okay, good, cleaned up again. So because we want to do that stuff in the shell, and yeah, this is our next command we have to learn. To move a file, we have the command mv for move, and we tell the file which we want to move, first file.txt, and we state as a second argument, we state the destination where we want to move it, and we say we want to move this file into this directory. So this is first shall try, and we move it, and you can see again in the GUI it's gone, of course not, but it's gone into this directory. And if we say ls, we see only our directory, but we can also say ls first shall try, so list the content of the directory first shall try, and we see our file again. Okay, then we can do as a next step, we could create the second directory, make directory, and we call it maybe first C program. Okay, and then we change into this directory first C program, a lot of first here, and okay, and now we want to create another file here, but basically we don't want to create it from scratch again, because we want to use a copy of our first file.txt. So we copy something. The command for copy is cp, copy, and yeah, we want to copy the file first file.txt into our directory where we are in now, in the first C program. So means that we want to have this file copied, or want to have a copy of this file going into this directory in here. Okay, let's try this. So copy is good, so we have to state the file, and the file is now because we are in the directory first C program, we need some means to navigate out of this directory, and this is dot dot. This means one directory up the hierarchy, slash, so slash separates one name in the path from the other, and so this means we are up from first C program in temp, and then we can go into first shell entry, first shell try, and then we say which file we want to have, first file.txt, and we want to copy it to the place where we are, into this directory where we are, and we can state this very simply by typing a dot. Dot means the directory where we are, and dot dot means the directory one step above in the hierarchy. So we copy it, and you can see we have first file.txt as in first shell try, as well as in first C program. Okay, now since the name is not the one we want to have, we have to change the name, and for this we can use the move command. We say, okay, we want to move the first file.txt into the same place but with another name. First, for example, first, or maybe no, hello world.c. And you can see that now the name of this file has changed from first file.txt to hello world.c. Just check out whether we have still whether the content is still the right one. We could, of course, to do that, we could open it again in the editor, but sometimes things go quicker if we stay in the shell, and we could type less for showing the content of a text file, and less hello world.c, and then you can see that we have this is still the text we typed in before in the text editor. With Q, the key Q, with this key we leave this program less, and we can continue our work in the shell. Okay, then let's go up again into temp. You see, we're in temp, and since we have our program in the first C program, so we have our file, and the first shell try is not of use anymore, we want to delete the whole thing. And for this we have two different options. The first option is that we delete the file first, rm for remove first shell try and first file.txt. So we want to remove this specific file, and no, the GUI doesn't. Okay, now we have it here in the GUI. So the file is removed, and then we can remove the directory by making rmdir first shell try. Oops, the directory isn't empty, so it did something in there. ls-a first shell try. There is a hidden file, the .ds-store. This it was done by our editor, so we have to remove this one. First shell try .ds-store. Okay, now it should be empty, and now we can try rmdir first shell try. Yeah, and it works. We can remove this directory. A somewhat more convenient way to remove the whole directory, but it's also more dangerous because you really remove the whole directory without any way of going back, would be rm minus r for recursive. First C program, and you can see we removed the whole directory, including all the files in the directory. Okay, now let's see. We have lots of different commands already, and there is one special command which can give you help on the different other commands, and this is man for manual pages. And for example, you can type in man ls and you get a description of the ls command, list directory contents, and then you see a lot of options. You maybe have seen it before when I worked and tried to figure out why the directory was not able to be deleted. I had the -a, and you can check this out. You can see here in the man page that -a means it also includes directory entries whose names begin with a dot, and these are special directory entries which are normally hidden, but with -a you can see them. So you can move around using the key cursors, key up, key down, and you can type in slash. You can see here down in the left corner here, and you can type some text, maybe, I don't know, operands, and then it searches all the occurrences of the words operands, and with n, the key n, you can go through all these occurrences here. Okay, good. Then let's go back to our presentation. And when we are so just to see here, you have the commands we used already. You have seen here. You have the man, and we also used the less command. There would be some alternatives to this. You can play around with these things by yourself. Okay, now it's up to you. I think I invite you to play a little bit around on your system. Log into your Unix box. Do some make your householding stuff to create the directory. Maybe you call it PR for procedural programming. Go into this directory, make a new directory called hello world, and create the file helloworld.c. This would be a first training to get a little bit familiar with these commands, and to get you into command of this. Okay. Then we have a few other commands like ps for looking for the running processes. We can also check out which other people or other logins are active on our system, and we can find specific files with grep. I'll show you this one here. Okay, let's go back to our shell. with Q. Again, Q is a very good key to end things. You know already from less, where we used Q, and to go back to the shell. Okay, let's type in PS. So we don't see too much here. Oops, sorry. Because there are not so many processes running uh, uh, which are tied to this shell, but we could say we want to have all the processes running on the system by typing in ps minus ef, and here you can see that there are actually running lots and lots of processes, which well, you can go through that and also look into your system what is going on there. Maybe you'll find some of some processes you know, or which look pretty familiar. Maybe you can find the web browser running and stuff like this. Okay, good. Then we could also type in who, and we can see that I am myself logged in on two different places on the console, and this is the TTYSC004. This is basically the shell we are working in here. But you know, Unix is a multi-user system, means that it could happen that you're working on machines where lots of other people are also working on, and so you can have a whole list of different people working on that machine. Yeah, and finally I'll show you two commands which are pretty helpful if it comes to searching for specific information, means files who have a certain name and or specific content. The first one, okay, assume we are looking for files which are somewhere on my file system, and which end with .cs, means which are C# files, and I don't know exactly where they are. I only know they are somewhere in my home directory in a def, but I don't know more. So I could start looking for these files by typing in the command find, and then I have to say where do I want to start my search, and I say okay, I know it's somewhere in my home directory, so this tilde is a shortcut for my home directory, and here in documents def I know there's somewhere there must be these C# files, and so I say okay, the name of these files I want to search for is something .cs, and I want to have these files printed. Well, and here we are. Here they are. Well, some files already. Let's go and go through that. Wow, that's a lot. There must be some end of here. Yeah, you see here, this is the command, and we have quite a lot C# files and found in this software, in this directory, my home directory, documents def C# triident trunk, etc., etc. And yeah, and so I can see here, yeah, okay, here are my C# files, and I can now maybe I can go into I copy this path here until here, copy, go down, we say we change into this directory. Yeah, we see quite a bunch of directories in here, and well, Then I say somewhere in, I don't know, just take one in scanner. I have these C# files, and I want to see all the files which have some members or stuff declared statically. So I want to know what is in the file, and for this I have an extra command. This is grep. Then I say I want to have I want to look for the keyword static, and I want to have searched through all the C# files, and then we have again here, this is the command, and here is the results. We see in keyword table we have several static members, a private static member, and stuff like here. So all the lines where static is found are listed then here in the terminal. So now here we are back in our presentation, and just to recheck what we did in the last minutes, we had the command ps, which listed us all the running processes. We had the command who, which listed all the users logged into our system, and finally we had grep and find for querying for specific files. Okay, this is now again your task, some small assignment where I ask you to play around on your system, check your processes out that are running on the system. Maybe you can do a little bit of investigation work, look through the processes. If you find one which are somehow familiar, be happy. If you find lots which you don't know, just Google some of them. You will find basically all of them in the web, and you can get information about these. Yeah, then at this point here, I hope you're alone on your system, because if it is your personal computer, there shouldn't be too many people on that except you. But finally, you can also look into the directory user include /user/include, which will be a very, very important one for our next weeks and months during this course. And well, you can, in this directory, you can, maybe using grep, you can find the files that contain the string get car. Yes, okay, good, we're nearly done. It was a lengthy session, but we have done a lot. We were going through all the we have been going through all the commands which we need for basic work. You can now work with files and directories. Here just show you all the commands we did in this area, listing the files, using ls, changing directories, making and removing directories, moving files around, removing files, copying, and using grep and find to search for specific files. You know how to get help. You remember this is the command man for manual. And yeah, and the very last thing is you know how to monitor processes and users. You have these two commands, ps for processes and who for finding different users. Yeah, that's it for this video. Hope it was helpful for you, and good luck for the assignment, and see you soon.